Welcome to this video on multiplying radicals. By the end of this video, you should be able to find the product of a radical expression, combine like radicals, write the product of radical expressions in simplest radical form, and differentiate between a rational or an irrational number. Alright, let's do a quick review that will kind of help us with what we're doing today. We're going to distribute the 2x through the parenthesis to the binomial that comes after it. So when I have 2x times 3x, end up with 2x squared, and then 2x times negative 4 is negative 8x. Okay, so when we did this, we multiplied the coefficients together. So 2 times 3 is 6, not 2, so let me fix that. And then x times x is x squared. So you multiplied the coefficients, you multiplied the variables. In the second term, you multiplied the coefficients, 2 times negative 4, and there was only one variable. It didn't have anything to multiply with, so it came along. This is kind of how our radicals are going to work also. So remember, if there's not a number in front of a radical, it's the understood one. So I'm going to write them in so we can kind of see them here. So we're going to multiply 1 square root 3 times 1 square root 2. So we have 1 times 1, which gives us 1. Square root 3 times square root 2 will be 3 times 2. Okay, then there's a plus sign. Then I have 1 times 2, which gives me 2. Square root 3 times 5. So let's take a look. 3 times 2, there's no pairs. These are prime, they won't break down, so we're going to remultiply them together and leave it 1 square root 6. Then we have our 2, 3, and 5. There's no pairs. These are prime. They're not going to break down. So it's going to go to 15. So this is going to be our final answer on this. Okay. So what we did is we took the term in front and we distributed it. So we will need to distribute the term in front to each term in the parentheses, and then make sure we simplify if possible. Okay, so let's try a couple and see how we do. So here we just have a 4. So we have 4 times 2, which is 8. 4 times, there's a 1 right here. Remember, negative 1 gives us negative 4, and there's not a radical to multiply to the square root of 3, so it stays square root of 3. Okay. No simplifying that can happen, so this is our final answer, and it is irrational. We'll try it again. This one's a little more complicated. So I've got the square root. Remember, there's 1s in front of these. So 1 times 1 is 1, and then I'm going to have 2 times 2. Then I have plus 1 times 5. 5, and the square root of 2 has nothing to multiply to, so it's going to just come along and stay unchanged. Now, I have a pair of 2's there. That means a 2 will come out and multiply to what's already in front. Notice there's no single terms left here, so there's nothing to go under the radical, so we're not going to have a radical left. This was a perfect square. 2 times 1 is 2, plus 2 is prime. This is not going to simplify anymore, so I can't do anything else to that term, and it's going to stay 5 square root 2. It's in simplest radical form. It still has a radical. It's irrational. Alright, so we can apply the same rule to finding area also. So find the area of a rectangle. So I like to draw pictures when they tell me that it has a side length of square root of 10. And then another side length that's square root of 2 plus square root of 10. So remember, when we're finding area, it's length times width. So usually you guys do better if you put the single term up front. Square root of 10 times the square root of 2 plus the square root of 10. Now we're going to distribute. There's no coefficients on there. It's 1, so it's not going to change anything. So I'm going to multiply these two together, and I'm going to get 10 times 2. And there's a plus sign. And I have 10 times 10. Okay. 10 can, this 10 right here will break down. Let's go 5 times 2, which gives us a pair of 2's, which means 1 comes to the front. And the 5 is left behind. This is our regular simplifying that we've been doing for a few days now. So we have a 2 that got to come out front and a 5 that had to stay behind. On this radical, I have a pair of 10's. Whenever you have a pair, you can bring one out. And there was no single terms left behind. That means this was a perfect square because the side lengths were the same. And the radical is going to go away. So it's just plus 10. Simplest radical form still has a radical, irrational. One last one. We're going to find the area of a square. So instead of a rectangle, we have a square with a side length of 2 square root 3. Well, it's a square, which means this side is also 2 square root 3. So we're going to multiply 2 square root 3 times 2 square root 3, coefficient to coefficient. 2 times 2 is 4, square root 3 times 3. There's your pair. That means a 3 can come out. And there's no single terms left behind. That means your radical goes away, and we have 3 times 4, which is 12, which is a whole number, so it's rational. Okay, hopefully that was helpful. Let me know if you have questions. I'll see you in class.